Hello Clouds Guru. Welcome to our next video on IPv6 theories and securities. In this video, you will learn much more on securities on-prem and on the cloud. So let's begin. We will discuss in this video the IPv6 topic in AWS. A first small portion of IPv6 theory, especially IPv6 types of addresses explanation. Next, shared responsibility model and implication on IPv6, the short history of evolving AWS services, and why we need to have IPv6 in our AWS environment, put us in the position that we need IPv6 solutions because of IPv4 exhaustion. The last bit of our video goes through AWS services that support IPv6. Let's start with basic theory. I will present selected information which can be helpful in working with the AWS cloud. IPv6 is 128-bit. The 128 bits of an IPv6 address are represented in 8 groups of 16 bits each. An example of this representation is this format being highlighted on the screen. For convenience and clarity, the representation of an IPv6 address may be shortened. One or more leading zeros from any group of hexadecimal digits are removed, which is usually done to all of the leading zeros. For example, the group 0 DB8 is converted to DB8. The group of quadruple zeros is converted to 0. Consecutive sections of zeros are replaced with 2 colons. This may only be used once in an address, as multiple use would render the address indeterminate. RFC 5952 requires that a double colon not be used to denote an omitted single section of zeros. ::1 is a loopback address in IPv6 and ::/0 represent default route. How to HTTP query on the web browser? Simple. After HTTP ::/ prefix in the square bracket, put the IPv6 address. Then second option is HTTP ::/ prefix. Then in square bracket put IPv6 address, then port number with the path to the page. Types of IPv6 addresses are global unicast, unique local, multicast and link local. Prefixes for IPv6 addresses. Global unicast has 2000::/3, unique local has FC00::/7. Multicast has FF::, and link local FE80::/10. Let's focus on global unicast structure now. Prefix is 3 bits, then 45 bits global routing prefix, subnet ID is 16 bits, and then 64 bits interface ID. Quick math, and we can say that subnet ID supports 65,535 individual subnets. AWS allocate the first 8 bits from 16-bit subnet ID to each IPv6 VPC. The customer has 8 bits to administrate subnets, no less than 256 combinations. Link local address does not leave the IPv6 subnet. It is the unicast address automatically generated on any interface, using the link local prefix FE80::/10. This prefix is combined with a 64-bit suffix, which the host can compute and assign by itself, without the presence or cooperation of an external network component like a DHCP server, in a process called link local address auto-configuration. The second 64 bits part represents interface ID. Unique local address has FC00::/7. A unique local address is an IPv6 unicast address that is globally unique, and is intended for local communications. It is not expected to be routable on the global internet. Prefix is 7 bits, then 41 bits global ID, subnet ID 16 bits, and then 64 bits interface ID. That was quick IPv6 theory. I want to show you a Cisco book, IPv6 Security, Protection Measures for the Next Internet Protocol. This is a very good book which is required for Cisco CCIE security exam. I can definitely recommend it for Cisco engineers. How about AWS engineers and architects? Do they need to know deeply on how to secure IPv6 protocol on routers and firewalls? Honestly, from my experience it is not needed. One place where we do daily basis security is Network Access Control List and Security Group. Thanks to AWS Shared Responsibility Model, that saved us from reading Cisco books. Let's jump to the AWS Shared Responsibility Model topic. First, definitions related to AWS Shared Responsibility Model are AWS Responsibility and Customer Responsibility. AWS responsibility refers as security of the cloud, which means AWS is responsible for protecting the infrastructure that runs all of the services offered in the AWS cloud. This infrastructure is composed of the hardware, software, networking, and facilities that run AWS cloud services. While on the other hand is customer responsibility, which refers as security in the cloud. That means customer responsibility will be determined by the AWS cloud services that a customer selects. This determines the amount of configuration work the customer must perform as part of their security responsibilities. That means security and compliance are a shared responsibility between AWS and the customer. The shared responsibility model diagram explains who is responsible for what. This video is about IPv6, so let's determine who is responsible for what in the IPv6 AWS environment based on the example. We are going to configure VPC with subnets, route table, network ACL, internet gateway, ingress-only internet gateway, and DNS. Then on top network infrastructure, we will add an application layer with EC2 instances, security groups and session manager with VPC endpoints. This is categorized as infrastructure as a service, or in short IaaS, and, as such, requires us to perform all of the necessary security configuration and management tasks. We are responsible for route table configuration, but AWS care for the hardware of network infrastructure. AWS must patch switches, routers and firewalls. AWS must do IPv6 hardening on network appliances. The AWS engineers must know the book that I presented early. We are responsible for who is allowed to get our EC2 instances, meaning for the AWS provided firewall, security group and network access list configuration, we are responsible. Our developers who build applications on EC2 must care for the security of the code, and we must know OWASP 10 principles and follow best practices to develop code. We, who deploy an Amazon EC2 instance, are responsible for management of the guest operating system, including updates and security patches, any application software or utilities installed by the customer on the instances. I will talk a bit about the evolution of using the AWS cloud and why we must use IPv6 in the cloud now. The first step was that company moved out of the data center and into AWS, and if it happened around 10 years ago, the landscape that AWS had at the time was very different from what exists today. There was no concept of VPCs. You could create just EC2 Classic instances. The network mode of EC2 Classic is very simple. Flat network shared by all customers. Every AWS customer gets a private IPv4 address, with AWS security groups. Deployment spread across multiple regions. Around 2016, AWS introduced VPCs, so EC2 Classic instances moved into VPCs. It's a flat network with non-overlapping IP space. You could peer them together, enable routing between VPCs, and add security groups to allow or disallow communication. In recent years, container deployment has become more and more popular, so moving workloads from EC2 instances over to containers has become a natural process. If we talk about containers, we need a number of IPs on an ENI. They are often short-lived. Containers come up, use the network, and go away within seconds. The environment is really dynamic. Can you think about the life cycle of an IP address? Requirements for VPCs increase with full IP reachability. Plus on top, we can say our company acquired another company and overlapping private IP addresses occur. Unexpectedly, new IT solutions caused the exhaustion of IPv4 private address space. As we mentioned before, we have a problem with private IP address exhaustion in the AWS environment. Let's check what happens with public IPv4 address space. Based on the date from ipv4.potaru.net, the remaining 220,992/8 addresses block are available for use in the public IPv4 Internet. Now, we don't have a choice. We must use IPv6. So why IPv6? Reasonably, these are the benefits of using IPv6. First, economics, and second is because of security. For economics, IPv6 is faster than IPv4, then eliminates boundaries that we have with public IPv4 versus private IPv4, and also eliminates middleboxes and operational risk. Lastly, for security, IPv6 is more secure than IPv4. Quick summary. IPv6 is problem solving. No network address translation in short NAT is needed. AWS introduce Elastic Network Interfaces prefix delegation. Customer can assign a private IPv6 seeder range, either automatically or manually, to your network interfaces. By assigning prefixes, you scale and simplify the management of applications, including container and networking applications that require multiple IP addresses on an instance. IPv6 help us continued growth. AWS services support for IPv6 include support for dual stack configuration on IPv4 and IPv6 or IPv6 only configurations. At the moment of creation of the video, we have 29 services that support IPv6, and the list is growing. We have additional IPv6 support. Some of them are Amazon VPC supports creating IPv6 only subnets, then Amazon VPC, which helps IPv6 AWS resources communicate with IPv4 resources by supporting DNS64 on your subnets, and NAT64 on your NAT gateways. AWS Identity and Access Management supports IPv6 addresses in IAM policies. AWS Cloud Trail records include source IPv6 information. For this part, we have covered basic IPv6 theory, including address structure and type of addresses, including global unicast, unique local, multicast, and link local. Also, we have tried to show how difficult IPv6 security is in traditional on-premises data centers. Then we jumped to AWS Shared Responsibility Model fundamentals of security and compliance responsibilities between AWS and the customer. And I showed you that IPv6 security in the cloud, is less complicated than traditional on-prem security. Next, I will show you how IPv6 evolved and why IPv4 private and public addresses are exhausted. And lastly, I presented a list of AWS that support IPv6 protocol. Before I go, I want to share some overview for the next video where you will learn more about subnets type in AWS, IPv6 cases scenarios which includes IPv6 only subnets, application and network load balancers, then dual stack, and lastly AWS Transit Gateway. Video 3 and 4 will present IPv6 demo where we will build network IPv6 only infrastructure and test connectivity. And there you go. It has been another journey in learning with us. Thank you so much for joining me, and I had a great time in this video. Looking forward to having you in the next to come. And I hope this has been very informative for you, and I'd like to thank you for watching. Don't forget to like, subscribe, and be sure to click the notification bell for you stay updated on my next video. See you next time, gurus.